The Western Coast of Chile by Ethan Kadauka. So just a short introduction first. My name is Ethan Kadauka, and this is my 4th semester here at Madison College. I'm 20 years old, and I'm majoring in atmospheric and oceanic science. For the Unit 2 assessment, I've chosen the coordinate 46.237 degrees south and 75.7729 degrees west. This places my location just off the western coast of the South American country Chile. This location is also known as the Chile Triple Junction. The Chile Triple Junction is where the South American Plate, Antarctic Plate, and Nazca Plate all intersect at one point. This general area is filled with plate activity. Where the Antarctic Plate meets the Nazca Plate, it forms a divergent plate boundary called the Chilean Rise. The Chilean Rise is a mid-oceanic ridge. Towards the eastern portion of the Chilean Rise, both the Antarctic Plate and the Nazca Plate are subducted under the heavier continental South American Plate, forming a convergent plate boundary. A result of this process is the Andes Mountain Range, and also in 1960 the strongest earthquake ever recorded. This 9.5 magnitude earthquake created a massive tsunami which had a combined death toll of over 5,700 people. For Ocean Province, the Antarctic and Nazca Plates have created a mid-oceanic ridge, which subducts under the heavier South American continental plate. This is an active continental margin. Near the Chile Triple Junction, there exists a series of hydrothermal vents. These vents differ from normal hydrothermal vents in that these vents do not release the same amount of metal particles into the water as normal. A possible explanation for this is that since the hydrothermal vents are much closer to plate margins than average, the increased sedimentation on the seafloor could be interfering with the release of these metallic particulates. For its ocean sediment, my location has terragenous sediment. This is the most common type of sediment and generally originates from islands, continents, or volcanic eruptions. The sediments are transported by both wind and water. The Chilean Triple Junction likely lacks other types of sediments because of the subduction occurring due to the heavier continental lithospheric South American plate. And here are my sources.